Hi everybody. In the previous video lecture, we have discussed about the performance metrics of computer. In this video lecture, we will discuss about the memory address and location of computer. We need a method of naming the place where main memory stores data. When location needs an unique name, just like houses in a town need a unique street address. Rather than a street name and house number, memory addresses are just numbers. A memory address holds 1 byte of data where 1 bit is equal to 0 or 1, that is on or off. 1 byte is equal to 8 bits, 1 kilobytes is equal to 1024 bits, and 1 megabytes is equal to 1024 kilobytes. You might wonder why 1024 instead of 1000 bytes per kilobyte. This is because computers do not count by tens like people. Computers count by twos or powers of twos. Memory locations and address determine how the computer's memory is organized so that the users can effectively store or retrieve information from the computer. The computer's memory is made of silicon chip which has millions of storage cells, where each storage cell is capable to store a bit of information which value is either 0 or 1. But the fact is, computer memory holds instructions and data, and a single bit is very small to hold this information, so bits are rarely used individually. As a solution to this, the bits are grouped in fixed size of n bits. The memory of computer is organized in such a way that the group of these n bits can be stored and retrieved easily by the computer in a single operation. The group of n bits in terms of words, where n is termed as the word length. The word length of a computer has evolved from 8, 16, 24, 32 to 64 bits. General purpose computers nowadays have 32 to 64 bits. The group of 8 bit is called a byte. The memory locations are addressed from 0 to 2 to the power k minus 1, that is, a memory has 2 to the power k addressable locations, and thus the address space of the computer has 2 to the power k addresses. Let us try some suitable values of k. 2 to the power 10, 1024, that is 1 kilobytes. 2 to the power 20, 1 megabytes. 2 to the power 30, 1 gigabytes. 2 to the power 40 is 1 terabyte. A memory word is certain bytes that bidirectional data bus can carry at a time. Say, size of the data bus is 16 bits. It means it can carry a maximum of 16 bits of data at a time. In such a way, we can say that the word size is 16 bits to 2 bytes, and such memory are called word addressable memory. In a 32-bit machine, size of the data bus is 32-bit or 4 bytes. So, a 32-bit machine has word size of 4 bytes. In such machines, CPU can write 4 bytes of data at a time from main memory. A reference to address 0 will read or write first 4 bytes of main memory, that is bytes 0 to byte 3. Similarly, address 1 will fetch bytes from 4 to 7 and so on. Note, in a system where size of data bus is just 8 bits, that is 1 byte, it becomes byte addressable. Byte addressable technique is simple. CPU just fetches 1 byte at a time from a main memory irrespective of the size of the data bus. Address 0 denotes byte 0, address 1 denotes byte 1 and so on. Earlier computer like Intel 8008 were byte addressable. In 8085 was also byte addressable, having word size of 8 bits. In figure we can see there are 128 bytes in the RAM, so RAM size is 128 bytes, but in the second figure, there are 128 words in the RAM and each word has a size of 32-bit or 4 bytes, which makes total size of RAM equal to 128 into 8 into 4, that is equal to 512 bytes. In word addressable CPU, access 4 bytes at a time using 32-bit bidirectional data bus, but in byte addressable size of data bus is 8 bits. Byte addressable memory or read only, that is, we cannot write to word addressable memory, but word addressable memory can be read or write both. In word addressable, we need two registers, memory address register and memory data register. The size of, that is, MAR and MDR. The size of these registers depend upon the computer architecture. Say we take an example of 32-bit machine having 4 gigabytes RAM. In this case, the size of the memory address register and memory data register are 32 bits and same as the size of the data bus. When CPU is on to fetch any data or instruction from memory, it places the 32-bit memory address into memory address register. This address is then used to calculate the address of memory word in main memory. Since the size of memory word is 4 bytes, a 4 gigabyte RAM will have 1 gigabytes of memory word, and to address 1 gigabytes memory word in the main memory, we need only 30 bits. Two higher order bits of 32-bit memory address are generally discarded to make it to a 30-bit address and placed in the memory address register. The 30-bit address is used to access a memory word. Address 0 points to first memory word, that is byte 0 to 3. Address 1 points second word, that is byte 4 to 7, and so on. The respective memory word is fetched and stored in the memory data register. In byte addressable, two different CPU registers are used, program counter and memory buffer register MBR. If we consider the same RAM size of 4 gigabytes, a byte addressable memory generally denotes not having such huge memory. Okay, 32 bits will be required to address, that is 2 to the power 32 bytes of RAM. So size of the program counter will be 32 bits. When CPU will fetch any data from RAM, it will place 32-bit address in the program counter. This 32-bit address will be required to address a certain byte in the memory. Address 0 will point to byte 0, address 1 will point to byte 1, and so on. After the required byte is fetched, it will be placed onto the data bus to store in the lower order 8 bits of memory buffer register. Different languages read their text in different orders. English read from left to right, for example, while Arabic read right to left. This is exactly what Endance is for computer. If my computer reads byte from left to right and your computer reads from right to left, we are going to have issue when we need to communicate. Endance means that the bytes in computer memory are read in a certain order. We won't have any issue if we never need to share information. Each computer is internally consists of their own data. It is just that the internet has enabled us to share more data that we never have before. And our data is not always read in the same order. Endane is represented in two ways. Big endane, that is BE, and little endane, LE. BE stores, that is big endane, first. When reading multiple bytes, the first byte or the lowest memory address is the biggest. So it makes the most sense to people who read left to right. LE stores little endane first. When reading multiple bytes, the first byte or the lowest memory address is the littlest. So it makes most sense to people who read right to left. If the above does not make sense, that's okay. Okay, let us look at an example. Let us take a number that we have to use multiple bytes to represent and show the big Indian and little Indian way it can be represented. We will take a number that requires 3 bytes to be represented in binary. This may slightly oversimplify it, but I hope it serves a helpful visualization example. The 0b at the beginning is just notation to let reader know it is a binary. So we know that the difference between binary 1001 and decimal 1100. I also used colors to hopefully make it clear. Okay, you just see the figure. I just want to be clear that the bit order is fine. There is no difference between the orders of bits, but there is a difference in the correct ordering of bytes. I hope the above demonstration what I have shown here is the order of zeros and ones within a byte don't change. Okay, but the byte ordering does change. If we only ever had to send one byte to, there would be no issues. It is only an issue with a sequence of more than one byte. Thus, big Indian and little Indian specifies the order of byte inside a word. Similarly, the bits must be labeled inside the byte or a word. The most common way of labeling bits in a byte or word is as shown in the figure, labeling the bits as B7 to B1 to B0 from left to right as we do in little Indian assignment. In a machine with word length of 32 bits, the word boundary occurs at the byte address 0, 4, 8 and so on. It is said that the word has aligned address if they begin with the byte address, that is multiples of the number of bytes present in the word. For example, the word address 4 has 4 bytes in it with byte address 4, 5 and 6. The word address 4 starts with the byte address of 4, which is multiples of the number of bytes in word 4. In case if the word address begins with the arbitrary byte address, the word is said to have unaligned address, but conventionally the word have aligned address as this lets the access of memory operand more effectively. So this is all about the memory location and how they are addressed to store and retrieve the instruction or data more effectively. With memory address, it became easy to identify a specific memory location. Thank you all.